Welcome to section 4.4. This is all about modeling and optimization. Throughout this series, we're going to look at a strategy for optimization, and then we'll get into examples from mathematics to business and industry to economics, and finally we'll end with modeling discrete phenomena with differentiable functions. This is about a strategy. No new definitions here. We will have a rule. It's really more of a strategy, and it's for solving max-min problems. So let's begin this way. While optimization problems constantly arise in a number of places, for instance, business and industry, economics, medicine and the life sciences, engineering, physics, chemistry, and basically anywhere that mathematical models are used, it is very unlikely that outside of a mathematics class, anyone will ever give you a function and ask you to find its maximum or minimum value. See, real-world optimization problems almost always involve first finding an appropriate function, then optimizing that function, and finally interpreting the solution. So let's read that sentence again because it's going to become very important. Most real-world optimization problems almost always involve first finding an appropriate function, two, optimizing that function, and three, interpreting your result. Once you know the function, finding the max or min usually is the easiest part. Throughout this section, we're going to practice taking a problem from its original statement all the way to the final interpretation of the solution. On the next slide, we're going to learn about the strategy to do just that. So here it is, a strategy for solving maximization or minimization problems, often called optimization problems, max, min, or optimization. So here it is. The first thing we want to do is understand the problem. Understand it. Read it carefully, identify information you need to solve the problem. I often will circle or underline or highlight key information. Number two, develop a mathematical model of the problem. This can often be the most difficult part. I suggest drawing pictures, labeling the parts, introduce variables for quantities that are unknown, that can't be controlled, and then use that variable to write a function whose extreme values will give you the information you seek. Number three, graph that function. Always helps to look at a graph, figure out what the domain of the function is, and determine what values of the variable make sense in the problem. Four, identify the critical points and endpoints. So that means we're going to be differentiating. Find the derivative, set equal to 0 or set it undefined. Find the critical points, and then find the endpoints using that domain back from number 3. Part 5, solve the mathematical model. So if you're unsure of your result, support or confirm your solution with another method. And finally, interpret that solution. Answer the question. Translate your mathematical result into the problem setting and then decide whether the result makes sense. So we're going to use this strategy on the rest of the problems in this section, but that does it for this video.